What is fatigue failure in polymers, and how does it happen? Have you ever wondered why some plastic items break or fail after repeated use, even when they seem perfectly fine? This phenomenon is known as fatigue failure in polymers. It occurs when a polymer material experiences repeated stress over time, leading to gradual damage. This damage can happen even if the stress is below the material's maximum strength, eventually resulting in cracks and sudden failure. Fatigue failure typically unfolds into main stages: crack initiation and crack propagation. Initially, tiny cracks form at points where stress is concentrated. These points often include defects or irregularities in the polymer structure, such as voids or flaws that may have been introduced during manufacturing. Once a crack starts, it grows a little more with each load cycle until the polymer can no longer handle the stress, leading to a sudden breakdown. The molecular structure of polymers plays a big role in how well they resist fatigue. Polymers with higher molecular weight and greater crystallinity tend to resist fatigue better. This is because their molecular chains provide stronger mechanical integrity. On the other hand, polymers with more defects or lower crystallinity are more vulnerable to fatigue damage. Environmental factors also impact fatigue behavior. For instance, higher temperatures can increase the movement of molecules, speeding up crack growth. Moisture can lead to plasticization or chemical degradation, further weakening the polymer. Loading conditions are another important factor. The frequency of loading cycles, the amount of stress applied, and the average stress level all influence how quickly fatigue damage builds up. High-frequency loading can cause internal heating, which may accelerate damage. Higher stress levels can lead to quicker crack initiation and growth. Understanding fatigue failure in polymers is essential for designing durable products. This is especially true for items that will face repeated mechanical stress, like polymeric fibers, films, and engineering plastics used in cars, medical devices, and everyday goods. Knowing how fatigue develops helps engineers choose the right materials and design components that minimize stress and environmental damage, ultimately reducing the chances of unexpected failures. In essence, fatigue failure in polymers is a gradual process where tiny cracks form at defects and grow under repeated stress, ultimately causing the material to fail. This process is influenced by the polymer's molecular structure, environmental conditions, and the nature of the loads applied, making it a predictable mode of material failure in polymer products.